Here's your video for simplifying algebraic expressions. When we look at a multiplication problem, what does it mean? Multiplication can be thought of as repeated addition. So 2 times 3 would be 2 plus 2 plus 2 3 times, or 3 plus 3 2 times. So it's important for us to remember always that multiplication is actually repeated addition. We can see it with numbers, and when working with variables, there are still times when we want to consider adding a variable repeated times. So if we were to add x plus x plus x plus x, that means we've done x 4 times, and we could write that as 4x. As we go through some examples, we'll break down variable expressions this way. It's helpful to remember the meaning of something like 8y, that it's actually y added repeatedly a total of 8 times. We'll also be utilizing two properties, the associative property of addition and the commutative property of addition. The associative property of addition, which we could summarize by writing a plus b grouped together and then adding in c, will always give the same result as if we were to group b plus c and add a. This statement is that when we are looking at only addition as the operation, we can group these numbers in any order and will always get the same result. A similar idea is in the commutative property, which we could summarize like a plus b equals b plus a. If you're adding two amounts, you can add those things in either order. So these properties help us say that we can rearrange the items in an addition and it will never affect the result. Some examples of these properties could be 3 plus 8 plus 2 would always equal 3 plus this group 8 plus 2. Order of operations will say always do the operation in parentheses first. Here we would get 11, and then 11 plus 2 would equal 13. On this side, grouping the 8 plus 2 equals 10, and 3 plus 10 equals 13. So we'll get the same result regardless of how we group these numbers in the addition. Commutative property would be something like 3 plus 9 is always going to equal 9 plus 3. The order won't matter in an addition problem. The result will always be the same. We'll also see some examples where we will use the distributive property, where we are multiplying some number or variable by a group of two or more numbers or variables. We need to multiply this number out front by each term that is inside the parentheses, a times b plus a times c. Some quick examples would be 3 times x plus 4. We'll multiply the 3 times the x and times the 4. 3x plus 12. Be cautious when we have a negative number in front of the parentheses that we're multiplying a negative to each of these terms. This would give us negative 2x plus 6. Negative 2 times negative 3 equals positive 6. We have to be cautious whether there's a negative number in front of the parentheses or if there's just a single negative sign. We would have to distribute the negative. It will flip the sign of each term in the parentheses. Negative x plus 3 for this example. We can also see examples where we're distributing a number to more than 2 terms. Here we'd have to distribute 3 times. 6x plus 2 plus 2y. And we'll even see a fraction that we would need to multiply through. Remember, when you're multiplying a fraction, you can use the numerator as the multiplier and the denominator as the divider. So 3 times 10 equals 30, divided by 5 equals 6. 6x for that first term. Multiplying the 3/5 times negative 3, we won't be able to simplify this fraction. I'll keep it as an improper fraction, 9 over 5. Now that we've got some basics covered, what would we do with an example like 3x plus 5x? Remember, 3x is representing an x added repeatedly 3 times. X plus x plus x. There's the 3x. The 5x is something similar. That's x added up a total of 5 times. Now the associative property will say that we can group all these additions in any way that we want. So it's not necessary to group the first 3 together and the last 5 together. We'll get the same result as just seeing it as 8x's all added up. Now we'll take this expression, which is written in kind of an expanded form where we see all the additions, and rewrite it with a multiplication. X added up a total of 8 times, so that's 8 times x, or 8x. So we can see a pattern or a rule where when we are adding up these terms that have the same variable, we just add up the number part, the coefficient. 3 plus 5 equals 8. And notice that we did not make any changes to the variable x. It stays x. And I think it's helpful to look at it this way. 3x is 3 x's added up, and we're going to add to it 5 more x's. So we still have the exact same type of variable, it's just an x. We've just created a longer list of additions. We now have a total of 8 x's. 8x, not x squared or any other change to the variable x. This concept works when we see subtraction as well. That's because subtraction can be thought of as adding the opposite. And negative 2x would be negative x plus another negative x. So 2 negatives with 7 positive x's, and some of these terms will add up to equal 0. A positive x with a negative x equals 0. Another positive x with a negative x equals 0. Just wiping them all out of there. But we're left with 5 x's. So you could look at it as 7 minus 2 equals 5. They both were a sum of x's, so our result is still a number of x's, 5 x's. Or you could see it as 7 plus negative 2. When we get to an example that has many different terms, we have to group the like terms. That would be terms that have the same type of variable can be put together, and the commutative property is what allows us to deal with these terms in any order. So I can take the 5x and add it to 2x. I can then work with the y's, plus 7y and minus 6y, and that works because we're actually adding a negative 6y. And then lastly, negative 3 plus 2. And now breaking down each of these terms, we would see 5 x's added up plus 2 more x's would give us a total of 7 x's. 7y's minus 6y would leave just 1y. We can write the 1y as just a y. No coefficient we know is actually a 1. It's still accurate to write it as 1y, and it might be helpful for you to do that, but it's the same as just y. Lastly, we have negative 3 plus 2, which would leave negative 1, which we could write as minus 1. You could write it as adding negative 1, and it would be the same thing. Most of the time, we would just see it written as minus 1. Now, there's nothing we can do to combine the 7x plus y, because these are two different numbers. We use multiplication to write repeated addition only when we have the same number added over and over and over. So there's x added up a total of 7 times, that's 7x. But adding a y doesn't leave an opportunity for us to write this as a multiplication, because now we're adding different kinds of numbers. So 7x plus y minus 1 is as simple as this expression can get. Looking at this next example, we have x plus 2 grouped in parentheses and then added with 6. We can use the associative property of addition to note that the grouping doesn't matter, and commutative property to say that the order doesn't matter. It's basically 6 plus x plus 2 in any kind of order we want. If I write it with the numbers next to one another, I can clearly see this will end up as x plus 8. If you were thinking of writing this as 8 plus x, that would still be accurate, because addition can be accomplished in any order and still get to the same result. But usually, we write the variables first and numbers by themselves, or constants, at the end. So these two are equivalent, but this is what you would probably see most often as the answer. X plus 8, with the variable put first, the constant at the end. In the example on the left, the parentheses didn't play a role. We just had addition we could do in any order. But this time, there's a subtraction in front of the parentheses, and that makes a big difference. We have to use the distributive property first. This subtract is going to flip the sign of each of these terms. Over here on the left, a positive sign doesn't affect any of these terms. It keeps them as the sign that they have. So plus x plus 2 is exactly what we did, a positive x, and there's the plus 2. But a negative in front of this group means that this is actually a negative x and a negative 2. The 6, which is in front of this negative sign, is not affected. And now we can pull these terms apart in any order we like, but what's key is that each of these terms has to keep the sign that's in front of it, because what we're actually doing is adding up the negative wherever we see a minus. So here we can very clearly see that the negative belongs with the x and the negative belongs with the 2. So when we rearrange these terms, negative x, the 6 is positive, so it can be plus 6, and now plus negative 2, we can get to a result negative x plus 4. The 6 with the negative 2 equals a positive 4, but the x was negative. So here's our simplified result, negative x plus 4, which definitely is the same thing as 4 minus x. We rearranged the terms, but the sign stayed with what was right behind it. The x is still negative, the 4 is still positive. Let's look at another example. We would need to distribute first 11 times 5x and 11 times negative 8. Now multiplying 11 times 5x, we actually have an associative property of multiplication. Since we are doing 11 times 5 times x, our only operations are multiplication, we can group these as 11 times 5 times x to lead us to 55x. And the 11 times negative 8 equals negative 88. Now bring down that plus 22. Next, we are combining our numbers. Negative 88 plus 22 would be negative 66. The 55x is the only term that has the variable x. So we're left with 55x minus 66. For the next example, we are distributing twice. 3 times x and 3 times negative 5, 3x minus 15. And now positive 7 times 2x, that's positive 14x. And 7 times 1, 7. Now we've got variable terms that we can combine. Remember, we can take these terms in any order, so we'll take the 3x plus 14x equals 17x, and then negative 15 plus 7 equals negative 8. And remember, we cannot combine terms if one has a variable, but the other is just a number by itself, a constant. Our next example is similar, two different distributes. First, 5 times 2x, 10x, and 5 times negative 3, negative 15. In the second set, we need to look at this as a negative 6. Distribute the negative 6 because we need to pay attention to our signs when multiplying to all of these terms. The result needs to be negative 6x plus 6 because this is a negative 6 times negative 1 equals positive 6. This is a very common place to go off path, so just be cautious anytime you see a negative number in front of the parentheses. So now let's combine our like terms, 10x minus 6x, 4x, and negative 15 plus negative 6 equals negative 9. Our next example looks kind of similar again. We need to first distribute this 2. 2 times 3x is 6x. 2 times negative 2 is negative 4. We have a negative sign, not a negative number. It's actually, though, like a negative 1. So you can think about multiplying a negative 1 to each of these terms. Or you could see a negative sign in front of parentheses as something that will change the sign of each term in the set of parentheses. Either way, we should come up with negative 2x and a negative 4, or minus 4. Now we can combine like terms. 6x minus 2x equals 4x. And negative 4 with another negative 4 equals negative 8. Moving right on to our next example, another case where we see we need to distribute first negative 15x, and then negative 5 times positive 1 equals negative 5. And these other terms are not in parentheses, so we are not multiplying to those two terms. They're staying as is. We can put together the negative 15x with negative 9x to get a negative 24x. And our constant terms add up to equal 0. negative 5, and positive 5. There's no need to write the 0 in our answer. We can just leave the term negative 24x. Now let's look at a few examples where we see our variable has an exponent. We can actually combine these two in a similar way, because 2x squared is x squared plus another x squared, and the 9x squared, I guess I should have chosen a smaller number, but 9x squares all added up, and that gives us a total of 11x squares all added up. So again, no change to the variable part, just to the coefficient, the number out front. We're seeing that we're taking a list of x squares added together and linking it up with some more x squares added together, and we have a total of 11x squared. It works for subtraction also. 5y to the fourth minus 1y to the fourth equals 4y to the fourth. But be cautious for any examples where the variable part looks similar to other variable terms, but they're actually not the same. In this case, we can only combine x squared plus 5x squared, those two together to give us 6x squared, but the 2x cannot be combined. It stays as a separate term. So simplified, it would be 6x squared plus 2x. The terms that have an x squared compared to the term that has an x are considered to be different terms. They cannot be combined with addition.